I want to make sure that everyone is in a group of 4 or less. There should not be more than 4 of you in a group. So if you'll just check your group to make sure there are 4 or less of you in one group. Okay. All right. So while you were coming in, you will notice that Kathleen and I passed out candy. Okay. So what we'd like for you to do is we gave one group, my group, received only one type of candy, which was the Starburst. The group over here, Kathleen's group, received a choice of many types of candy. So what we'd like for you to do is to log on to today's meet and describe how you feel about the candy you received. Okay, so let's look at some of the responses that we have. And I'll give you a moment to get quiet. Okay. One of the things I immediately noticed was when I got to the back of the room, someone said, well, I don't want Starburst. I want what they got. And I tried to, as politely as I could, say, no, this is what I have for you.
It wasn't very polite.
Okay, so Kevin, since he put himself out there, insisted that he have another choice. But I didn't have any other choices for Kevin. The only thing I had for Kevin was Starburst. But you could see that some people said they felt left out because they're diabetic. Okay? Some people said they liked having choice. Some people didn't mind the fact that there was only one type of candy. So what we want you to think about today is the concept of choice and having choice and how it affects our students. But I want to go up here. Let's actually look at some of the things that people said. I didn't get any candy. I didn't see a choice of candy that were offered. Therefore, I don't have any feelings either way. Isn't that how it is for our students sometimes? If they don't know they have a choice, it doesn't really matter to them. Okay? Someone said, I love Starburst, so I picked those out of the other choices. So even though they were given other choices of candy, they still chose Starburst. Okay? What's another one? I was just happy to get anything at all. I was especially happy to see that there were Whoppers in the basket. Okay? So they were delighted by another option, another choice. Okay? I love the idea of choosing my candies just as students love choices. Someone hit it on the head. That's exactly what we want you to think about today. So this is one of the pieces of technology we want to introduce you today. Some of you may be aware of it and have used it in your classroom. Some of you may use something similar called Poll Everywhere. But we wanted you to be aware that if you have technology in your classroom, even with smartphones and some of the devices your students have, this is something they can use. Okay? And then there was someone at the bottom that said, let's get the one about I saw someone getting chocolate. Oh, I saw others getting chocolate. Go down just a little bit. Oh, there we go. I saw others getting chocolate and wanted, I keep losing it.
Yeah, it keeps going down.
Okay, keeps going down. Okay, and wanted to switch for a Reese cup. So how do you think your students feel if they talk to their classmates and they realize their classmates are in classes where they have choices about what they can do and they do not have the choice? Okay? So it might make them feel left out. So this is what we wanted you to think about today, and hopefully through this exercise, you can appreciate the importance of students having choice in the classroom. So going back to our PowerPoint, you should be able to follow along with us on this. Okay, there's an importance of student choice, and some of you actually identified it as you did this. When students are given choice, they're engaged and they're interested. Okay, because they feel invested. They experience a sense of control, they experience a sense of purpose, they experience a sense of competence. And if you'd like to read the article, I've given you the link here to the article about crafting effective choices to motivate students. So having choice is an excellent motivator for students. It is for us as well as adults. Okay? So, okay, that's me. Okay. All right, that's me. Okay, yeah. So here are the objectives for today. Today we're going to be looking at challenge-based learning. And with challenge-based learning, you will see your students will have plenty of opportunities to demonstrate choice. And what you'll be able to do today is identify the big idea and their connections to the hook. So for the examples today, you're going to see hooks related to these unit challenges. You're going to be able to develop essential questions, identify societal impacts, whether that's locally, nationally, or globally. And you're going to develop and or understand the challenge. There will be some cases where you might have the students develop the challenge. There might be some cases where you feel like you need to develop the challenge, especially as you start with these units. And then finally, today you're going to be able to develop guiding questions. So these are our objectives for today's session. Are there any questions about these objectives? Okay. All right, so challenge-based learning. Cohort 2 has plenty of experience with challenge-based learning by this point. But those of you who are new, who are in Cohort 3, some of you may have used it or may not be familiar with it at all. So when we think about challenge-based learning, we're thinking about collaborative and a hands-on approach to learning for our students, in which they work with their other students, they work with teachers, they work with experts to solve real-world problems, which hopefully will deepen their understanding in their content areas. Now, there are some benefits of challenge-based learning. There are primarily 3. We talked about student motivation. Those of us who have done the units over the past year will say that we know that student engagement is definitely a plus and a benefit, and also the acquisition of 21st century skills. And I've also given you a link to another article, or cited another article that talks about these 3 benefits of challenge-based learning. Okay, so these are the steps we're going to be looking at today for challenge-based learning. As we share the examples, what you'll see is that Kathleen and Kelly are going to be sharing about the hooks that they use for their students. You have an opportunity to identify the big ideas for the units. You will be developing essential questions, okay? And in one case, you'll see an opportunity where the teacher developed the essential question. And as you start some of the units, for those of you in Cohort 3, you may find it more appropriate for you to give the student the challenge or the essential questions. You're going to develop and or understand the challenge, identify societal impacts, develop guiding questions, and complete instructional activities to prepare for the challenge. So those are the steps in the challenge-based learning. The one thing we will really not get a chance to get into today is completing instructional activities, because those will stem from the guiding questions. Okay? All right. And for your challenge-based learning, these are just some of the characteristics. We know that the essential questions do not have any right or wrong answers. That's the beauty of them. For those students who are smart all the time, they know all the answers, well, this is an opportunity for them to think differently and for them themselves to be challenged. But this is in your PowerPoint, so I'm not going to go through all of these, but this is just a reference for you. Okay, so before we move on into our first challenge-based unit, our first example, I'd like to give Cohort 2 teachers an opportunity to share some of the problems that your units address. Can I have a few volunteers to just talk about one of the problems that you feel like your units address? Because we're talking about societal impact. One of the things that I think I've learned through this experience, through teaching these units, is that sometimes, well, I'll refer to me, I didn't really think my students cared much about many societal issues or global issues, but as we started to get into some of these challenges, I found out that students really could connect to some of these issues and some of these challenges, and that was a pleasant surprise for me, because I know they're going to be taking care of me when I get old. So I'm glad to see that the things that I find to be important as their teacher is important. I hope they do. Yeah, I hope they do. There's no guarantee. So it was refreshing to see that issues that are important to me as an educator are also important to my students. So we're going to look at our first challenge-based unit, and Kathleen is going to introduce that to us.
Okay, so just safety though, we're working with 2 chemicals. The chemicals both are mild skin irritants. They're also dangerous if they get in your eyes. Don't ingest them. Any questions safety-wise? The eye wash is right up here if you happen to need it. Okay, great. So you've each been given a paper. We need one more paper, actually. Great. Yep. There we go. You can go ahead and address the top of the one if you want to while we're waiting, but we have one more that's coming to you. Most of you are wrapping up your conversations about energy and also about these reactions. Can you tell me, how does the ammonium chloride reaction feel? Colder. What were some other observations you made about that one? It felt cold. It got cloudy. What was the ammonium chloride doing? Dissolving. Not all of it. Wonderful. What about the calcium chloride? Hot, hot, hot. Yes. Very good. Okay. A little bit cloudy. And did that also dissolve? Not completely. Maybe depending on how much you put in. All right. Very good. So this is an example of the first activity, the hook. And then the next thing we're going to go into is talking about the big idea for this unit. And that's the second page that you have there, the R challenge page. For this unit, my big idea that I share with my students, because it's not taking place in the summer. I know right now you're probably thinking, why are we going to cold weather? It's warm weather. Please keep in mind that this takes place in October, right around homecoming time. It's the first cold football game of the year. This is the big idea for us for this unit, staying warm in cold weather. If you would record that on your paper, I would greatly appreciate that. This is kind of where we're going to keep track of the things that we are discussing with our teams and then also with our whole group. Okay, so this is going to be a time where you're going to continue working with your teammates, but there's going to be a part here at the beginning where I'm going to ask you to work on your own. What I'd like you to do is just brainstorm some questions that interest you about staying warm in cold weather. Okay, interest you. I also want you to keep in mind during this time the class that you are in chemistry class. So please, as you're thinking about that, how can you relate chemistry to staying warm in cold weather? All your questions don't have to deal with that, but keep that in mind, okay? So you're going to have 3 minutes to work individually. Then once the 3-minute mark rolls, then you can start talking with your teammates and sharing out. Okay, go ahead.
Ladies and gentlemen, didn't Kathleen do a great job of One of the things that I shared with Kathleen that we didn't have an opportunity to do before break because we knew you all needed the break was, we want to pose the class to see how many of you think if you were given a choice as a class, you would have come up with the same challenge that Kathleen came up with. If you think yes, raise your hand. How many think as a class you would have came up with the same challenge? Yeah. And the reason I ask that is because we are giving our students choice. And part of the choice we may give them is the challenge. So Kathleen could have taken a risk and said, let's see if we can come up with a challenge. And the class could have gone one way. But I told her I'm confident based on the hook, the essential questions that I saw, and the big idea that the class really would have come up with the same challenge she had in mind. And one of the ways that I have handled that is I have students give input about the challenge. And I have several of the same class. So I might ask Bell 1 to do it on a Google Doc, and Bell 2 to do it on a Google Doc, and then take it home and come back and say, based on the data that I've gotten on the Google Doc, here's the challenge. And what I've shown the kids is they have a choice. Now, do they have 100%? Is the choice totally theirs? It may not be. But again, students are motivated by having choice, so that is a risk that you can take, and if you have enough classes, then you can kind of sway the decision. But based on the information she gave, I said, you know what, they probably could have come up with that challenge on their own. And students feel empowered because they now know they are vested in the challenge that they're getting ready to do. Okay, so now we're going to switch gears. Sure.
And I think that that's what it comes down to, becoming more and more comfortable with giving your students freedom. For this, I was not comfortable doing that, right? That's something that maybe in this past school year, I was not comfortable with my students coming up with the challenge themselves. And just in my conversations with Lillian here, I'm like, well, maybe that's something I could stretch to this year, something that I could become more willing to do in my classroom. Because we're all on a continuum, right, about comfortability with these sorts of things. So something to keep in mind.
A question. Could you let them go on with their own challenge, like those that got done sooner? Because you're always going to have some, they're not going to be working at the same speeds. You know, so unless you
Absolutely.
give them a set time constraint as one of your things, you could, a group that finishes could go off on that other and try their other challenge.
Definitely.
Okay, now, so we've given you one science example. Now we're going to switch gears and give you a math example of challenge-based learning. So Kelly is going to lead us in the math example. Does everyone have a handout? Should have two handouts. Does everyone
Rest
have
of
two
them are
handouts?
coming.
Okay, Catherine is still passing them out.
That's half the room, doesn't have this one.
Okay, well, my name's Kelly Denew. I teach at Goshen Middle School, 8th grade. How many of you teach math in here? Okay, good. So you'll be entertained, hopefully. With this presentation, you're going to notice with Catherine's presentation, we went through every single step and we completed every single step. But now that you kind of know how to do it and you are familiar with it, I am going to run you quickly through an activity and quickly how you could do all those different items, but without going into a ton of detail. So, get out there soon. No, I'm just kidding. I just don't want to be redundant. But I did print off for you something I found online I thought was pretty cool. This is just a sample CDL rubric. So kind of when you're coming up with the ideas, it'll kind of give you a guideline of when you're creating these big ideas, essential questions. I just thought it was pretty cool. So you can follow along with it as we go if you would like to, or just store it in your binder. Okay, so this math challenge here, just a little disclaimer. Usually this is a hook. Actually, I'm changing it to a hook. The first time I did it, it was activity 1, but I think that it would make a better hook to go into what my challenge actually is, so that they get my essential question and they get my big idea. So the disclaimer actually is that usually I would have a set of these for each group in the classroom. But when I did this before, it took a million years, not really. It took like the whole period to do the one activity. So I'm going to just demonstrate for you with some of your help, and then that way we can go through it a little bit faster. Okay? What you see here, a couple items. This is called a velocity buggy. Anybody ever heard of a velocity buggy before? Okay. Well, it's battery operated, and it's a constant velocity buggy. Okay, so it does go in a constant speed. So I did have to modify a little bit. I glued some straws onto it so that I can make a track, because I'm actually I want to know what the speed of it is, but if it wasn't on a track, it just kind of goes wherever it wants to. So that's kind of what we're dealing with here. Okay, so let me give you the scenario here. So we have two crazy teenagers, and they decided to play a friendly game of chicken and driving a car. So when I told my kids this in class, they're 8th graders, they're like, chicken, like in the swimming pool? And I'm like, no, like with a car. They don't drive, so they don't really get it. So I kind of explained, and they're like, that's stupid. I'm like, I know, right? So keep that in mind. But when they get to the teenage years, we kind of put out the scenario that if we knew if one of the kids was really, really good in math class and they could predict the time at which to pull away so that they looked like the coolest guy, the very last second pulling off without, pulling off too soon. So that's kind of what we're going to do here with this activity. So first, if you guys have that packet there, first what we're going to do is we're going to determine the velocity of each buggy. Okay, because one of them actually goes faster than the other one. You can do that for different activities. But for this, I'm going to need some volunteers. Can I have a couple people come and hold the strings? Because the problem with this, you have to hold really tight. Otherwise, it's not going to go straight. So, yeah, come on up, please. Come on up. Okay, and then, so you want to... Come on, Kevin, we need you. Come on up. We need you. We need an eyeball. Okay, so you'll have to crouch down on the ground. Okay, and we need this to go all the way back, so as long as the string goes. I've marked off into 2 sections. There's a red section here, red section there. Keep on going if we could, keep on going. Okay, wait, stop. So can we get that part? Okay. So what we're gonna do at this point, I'm gonna pull this back here. We're gonna figure out the velocity of each foot. So with two hearts, I'm gonna ask that this be pulled back to where the pink heart is. So we're gonna be judging from the front of the car, okay? And I'm gonna say how far can the car go in 10 seconds. So that's your job. You're the eyeballer. So we really, really, really need you to, when I say stop, you kind of get where, here, we'll put this in. Wherever the car is, you kind of just, put your finger there, and then I'll stop the stopwatch, okay? So this is just kind of a little bit of prep work. Let me get my timer. Okay, so again, the point of this is just to know how fast this car goes. So, and again, everybody would have these in each of their groups. All right, stopwatch. Okay, so when I say, actually, I'll just turn this on. So hold it real, real tight. Okay, ready? And maybe. We're gonna have to stop. All right, we're gonna have to pull this a little bit further, actually. Oh, we could have done that, sorry. See, students are being smarter than teachers. Yeah, so one of us actually faster. Okay, for real second. Got it, yeah. Ready, set, go. Okay. For real this time. And that's why you have to pull it so tight, otherwise it's going to veer off. Stop.
You turned off on this today.
Okay, we're going to do this in centimeters. How many centimeters?
357.6.
Okay, so drop this off to the side, 357.6 centimeters. That's for the blue car. And how we're going to do that, we're going to kind of figure out how fast it goes per distance over time, distance divided by time. So take a second, take your distance divided by your time to figure out our rate here. 10 seconds, sorry.
What was it, 357?
357.6 divided by 10.
Are you kidding
Okay, let's get first five. Good job. All right, let's do the red one now. Hopefully this one's faster. But you see how this could take a little bit of time for kids. They get all disorganized.
Is there a reason that you're doing the distance traveled in a specific amount of time compared to travel a certain distance?
Not really.
Okay.
Just
So I didn't know if you were working in a certain way.
This was easy to do math. Well, just
the calculation
here.
so why
Yeah.
would we do that?
Okay, oh, here's the finish line when it starts, when it hits the finish line, then it's your time.
Okay, ready, set, go. Yeah, I just did it kind of No, I'm not. I know.
443?
Perfectly.
Did everyone get
I
that?
was a little slow on the uptake.
440.
Yeah, we're going to call it 0.0.
Yeah, 4 that's our time.
How many seconds?
10 seconds.
So at this point, so now we're going to set up this scenario. We're going to actually set up the car crash that happened, but in about 5 minutes here. You guys want to come back in a couple minutes? Okay, so at this point with the math lesson, I would ask the kids to kind of start thinking about, you know, at what point, if these two cars are playing chicken, at what can we predict at what time they're going to run into each other? You know, it's that famous train A leaves the station at train B. This is systems of equations, and we have to do it in the 8th grade. I think they do it in the 9th grade as well. So as much as we hate that problem, it's actually kind of interesting when you put it to light for them. So at this point, where it says create an equation, I'd like for you and some of your teammates here to see if you can write an equation for both cars. Okay, so you can use the, well, I'll just let you guys come up with it. Eyes up here. Okay. Let's write two equations, keeping in mind that the red car is the blue car is the start, the red car is the finish. So keeping that in mind is really important. So for car A, we're going to call that the blue car. What's the equation you came up with? Anybody?
Y equals 5.76 times x.
Great. Awesome. And then how about car B? Oh, I kind of forgot to tell you. This is actually kind of important. That this car right here, the beginning car, is located at, the start point 0. But I didn't tell you how far away the end point was, which is 500 centimeters. That's kind of a big deal, right? So that's kind of going to be our next part of our equation. Okay, so knowing that, car B, what's going to be our equation here? Thomas?
Y equals 500 minus 44.3.
44.3?
Yeah.
X?
X.
You guys agree?
Yes.
Okay, because that means the starting point for this one. And the time, it's not like the time is negative, but we're going towards the point of velocity here. So now that you have two equations, this is where the kids would have had a little bit of background on systems for me. So I'm going to ask them to use a table, graph, or just solving equations to come up with the point where you think the two cars would crash. So work with your group. I'm going to give you probably about 5 minutes at this point so that you guys can come up with, you don't have to do all three, okay, just choose one method. Thanks. All right, so if you haven't done so already, would you please, one of your group, if you can, go ahead and put your prediction up there if you would like to be eligible for the competition here. See who got the closest. But it looks like we're kind of around the same. I've never really used a Google Doc for a whole class. Oh, can I have your attention? Shh. She doesn't even know I'm telling her to shh. Not really. Anyways, so I'm kind of trying it out with you guys with using Google Docs. So I don't know if necessarily putting the answer on there would be the best way because they can see the answers, but I certainly think that you can use a Google Doc for other ways of communication, which you will see later in my demonstration here.
Can I mention too? Another way you could use this is to do a Google form where they could enter it, and then the spreadsheet you could show them later, because we know that our students don't have the same level of integrity as your colleagues here. So you could do this as a Google form where they just enter the number and then later show them the data, how they compare.
Okay, so at this point, I'm going to I'm going to kind of show the answer. I'm going to ask that, does anybody want to show theirs? Does anyone have a table that they like, that they did and they want to show us? If I can figure out how to do this. And so nobody solved it using a table. Did anybody try a table? Okay, because this is where we would go into the conversation with the kids that the tables sometimes you can do them, but they're not, you can't get as accurate with the tables because unless you're working with whole numbers, you have to dig a little bit deeper into the decimal numbers. That's kind of why I used time. I don't know why this is working. Yeah. Oh, it is. Because I have nothing there. All right. Does anyone want to show us their equation that they did? Did anybody use equations to solve? Samantha, would you like to come on up? Sure. Everybody did. I heard somebody said they were using. Yep. There we go. So this one I would kind of tell, sometimes the kids are like, why do we have to do it this way? And just if you're, not working with whole numbers, you have decimals, this is why. But again, I don't have to get all into the math lesson or anything, but that is awesome. Good job.
By the way, I'm a science teacher, and I even did algebra.
Wait. I am a science teacher. Samantha, would you mind sharing it with some of the science teachers how you solved it?
Sure. Well, I had the help of, I have 3 math teachers in my group, so they're very helpful reminding me how to get started, because they were using all these crazy methods. But basically, I just took my 2 y equations, my 2 y equations, and since they were both equal to y, I just set each of those equations equal to each other, and then we simply solve for x.
Very good. Yeah.
Are there any questions about how that was solved? I'm sure you worked it out with your group, but I just.
And did anybody attempt a graph if they could show us? Nobody? No? I know. It's kind of the way we're taught too. I feel like I went the fastest route too. And then, did Lillian say that someone was using matrices back there?
We started to, and then we decided since the equations were already solved for d, we decided that that'd be easier, and we were lazy.
That's it. Be sure on it. So, all right. So at this point too, I have all the different numbers ready to go. So we'll see who is actually correct. Now, hopefully this works. It did in my classes that time. So if you guys want to come back up and we'll see if it really is. I think people said 6.24, 6.25, 6.245. And so it's going to be really important that we, let's hold that right here at the starting point. And then Kevin, can I ask, when the front of the cars, well, that's the new where they crash. Yeah. And then, yeah, awesome. Okay, so you'll be the eyeballer again.
You gotta start that one?
What's that?
Oh,
Somebody's gotta stop
so
the cat.
maybe, actually, if you want to pick them up and just hold on to them and then just put them down, drop them when I say start. Okay, ready?
No.
No?
Oh, that's my mark. There we go.
Ready, set, go.
Go my boy, Blue. Go, Blue. Woo! Yeah. Go.
Okay, so, oh, he's even pushing them back. All right, so, anyways, it was 6.69. So you're very, very, very close. Did anyone get?
I say that they stretched the string too much and made the distance farther.
And something that was different than when we yeah for the that was something. All right, so 6.48. Hey, they 6.5. Yeah, Jesus. All those because it's going to be this. Yeah, that one there. Wow. No. Oh, I like that.
What did they say?
She said 6.25 plus 0.25 equals 6.50 to account for the distance the film travels to get to the stop button on the timer. There are 3 significant figures in the original equation. You guys definitely deserve to be the winner. So I got you your very own Teacher of the Year award. Oh, now you would like that. There you go. I even signed it because I know that you would like my signature. There you go. Yes. And if anybody wants some extra coffee. In case everybody got it, I was wondering. Okay, so that's kind of my book. That was kind of my book. Now we can kind of go into the challenge-based learning part. Again, I used that as one of my activities before, but I do think, and tell me what you think, because this is going to be honest feedback for me for when I do this again this year. I think that it'll kind of get them thinking towards what my big idea is. Okay, so systems of equations, the easy definition, I'm sorry math teachers, is the point at which two or more things are equal. And I know we hate these word things, but the infamous train A, train B problem, profit versus income. Cell phone companies, sometimes you can pay for text or monthly flat fee. Comparing different companies' rates and prices, such as like if you have a membership fee versus just item rates. Owning a Prius, I know that Catherine owns a Prius, but like the cost of the car versus the gas mileage, or when will the benefits outweigh the cost, the gym memberships, a monthly fee, or can you pay per visit, or just an annual fee? Can you guys think of any more? Now this is just real world context, something that hopefully we got a lot up there. Think about it. Anything in the real world that we can apply the same type of concept to as to when the two would be the same.
Something similar to the Prius, doing like a fuel efficient house, building it up front versus the cheaper house, and when do they equal
That's,
out?
we actually went on a field trip yesterday in one of our classes, and that's something that they were saying. If you're building a new house right now, it's definitely, what do they call it, Samantha? Geothermal? Geothermal, even though, I know Samantha looked into actually building a geothermal house, and what did you say, it was like $20,000 to put in?
Yeah, the initial cost was about $20,000, and it would have taken us about 15 years before we saw any kind of payback. And we don't know if we're going to be in that house for 15 years. So
So it would pay off if you were going to be there for 15 years, but this is exactly the kind of example that we're talking about. So, yes.
One of the sample Parker Smarter Balance questions, I'm not sure which, I think it's for 8th grade, is a pretty complicated one that has a woman who bought all this energy efficiency upgrading, and the person who sold it said you'll be able to recoup your money in this amount of time. It didn't happen, so they had to analyze why, and whether the winter's extra cold or whatever. So
That's a good
something like
problem.
that.
Yeah. So kind of going with that, moving on here, my question to you is how can we use this particular math concept with something that has global relevance? And then hopefully I'm leading here, I'm leading them to my challenge. Something that I read about that with CDL, when you're trying to find global relevance, pick up the newspaper, read the internet, get something that matters, or something that's in the news, and that's how you can kind of develop what your big idea is going to be. So when I did that, something that I found to be interesting was how you can use submarines for rescue missions. So I thought that was pretty cool. So submarines are valuable to us because they are used to establish and maintain peace, and they can explore the depths of the ocean not reachable by any other means. They can also be used for rescue and salvage missions in cases involving sunken or disabled vessels. Okay, so kind of keeping that in mind. Keep the big idea and that math concept that we just learned in mind, and then I want you guys to brainstorm with your group 5 questions that we could explore using and relating submarines and the math concept system. Usually you would let the students do it by themselves for a couple minutes, but again, you've already gone through the whole process. So I'm going to give you 10 minutes. By the way, after you guys have done the 5 questions, I want you guys to find the top idea, or you guys agree upon the top idea, and then I want you guys to enter it into the Google Doc format. This is kind of a way that I'm going to quickly see what our question will be. Okay, 10 minutes. Because we want to kind of get you guys out of here early, I'm just going to quickly kind of go through this. Again, this is the first time I've ever used a Google Doc to show the essential questions. I like it. Just being the teacher up here, I can see very quickly. Although you do run into problems like troublemaker Kevin over there. I'm sure it was him. Is Sean Connery going to be there? But I answered back. So let's see. How fast do submarines sink, rise, and travel? That's very important to know. Where should the submarine start its descent to reach its target? Also very important to know. Are submarines faster than the other ocean rescue vehicles? And are they better equipped to perform rescues on and underwater? A team biologist wants to tag a certain species of fish that travel a particular path throughout the ocean on a daily basis. That's a really good idea.
She's like, go.
Might steal that one. How fast can a submarine travel through the water in any direction? Finding the black box of an airplane that is now on the ocean floor. How do we engineer a submarine to change its density in water to sink, locate the other object, and float back up to the surface? It's like I planted someone in the audience. How long would it take to overtake an enemy submarine that is traveling slower than our sub? What is the optimal depth at which the submarine travels? And where is the sub going? I like all of these, and they're all very similar. They all kind of go together here. And I was talking to Kevin back there, and he said, and he and his group, me too. He and his group said, you know, in high school we could use this. Did you say with vectors?
Vectors.
That's
Because
cool.
it's just magnitude and direction, and it's like yours is one-dimensional. They're going at each other. We can put them on angles and then look for where they cross.
I like that. So I feel like with all of our different backgrounds and what we teach, there's so many variations of the way this lesson could go. So without further ado, I will tell you, I was going to put a different result here, but here was mine. How can we engineer a model submarine with a changeable density so that it can sink in the water, rise back up to the surface, and predict the time at which it will meet a scuba diver needing oxygen? So that was the essential question, so I was really glad that you guys hit it. So now we can move on, and you can say, wow, you guys came up, all right, I came up with a great lesson, let me go home and I'll get it all together for you, and then they'll really take ownership of that. So that's awesome. So here was my challenge. It's kind of wordy because you can either read it on your computer or I'll just read it to you here. It just kind of tells them that submarines are being used for many purposes, ranging from naval defense to recreational uses. They allow humans to safely explore parts of the deep ocean that were formerly inaccessible, making important discoveries and also performing important tasks such as rescue missions and asset recovery. This is the actual sheet I gave them. Modern subs can dive down to depths of hundreds of feet and stay for long periods of time before resurfacing. In order to do this, however, engineers had to figure out a way to make a vehicle with a variable density. After all, nobody wants a one-way trip to the bottom of the sea. So in this challenge, you and a fellow engineer will design a working model submarine using a 2-liter bottle and several other materials. I am actually going to change that this year to a water bottle. You will be rescuing Scuba Steve, who is near the bottom of the ocean. Scuba Steve can only rise up to the ocean surface at a very low rate due to all the pressure in the ocean. He also has a limited supply of oxygen, so he really needs your help. You must complete the following. So design a submarine that will move up and down due to changes in its density. Have the submarine sink to nearly the bottom of the tank and hover there long enough to rescue a scuba diver. Determine a point of intersection between the submarine and the scuba diver based on mathematics. Complete the rescue and rise to the surface in less than 1 minute. I ended up making that a challenge. I ended up saying like whoever got the fastest, even if you didn't get it done in a minute, you were the winner. And then a challenge using magnetic force. Design a sub that will allow the scuba diver to actually connect to the submarine. Most of them use magnets. So that was the challenge, and I think I used for them, that goes into my guidance question, sorry. So at this point, you could use the same method as we did to find the essential question. Here's the today's meat. So guiding questions, this is kind of what are you going to need to know to figure out this challenge? What I need to either supply you information with, or what do you want to know at the end of this unit? So we'll use a today's meet again, and if you guys just want to work together on this, you can just one person's name. And we'll just go like 2 minutes because you really already know how to do this. These are all really good questions. We were just commenting and seems like a lot of you are being tired with some of the responses. So, saltwater or freshwater makes a difference because we know that saltwater people float better in. Why am I here? I don't know. We need to see how
don't even know what you're doing.
Let's see, is the water hot or cold at room temperature? Oh, I guess I should really be answering this question. Someone said, is Scuba Steve cute? I happen to bring Scuba Steve with me. Who said that? You can make your own judgment. Here he is. This is really what I put at the bottom of the ocean. He's wearing a tuxedo.
Oh,
He's on a little magnet. Anybody? Yeah. I think he's pretty cute.
that's well for his dive.
I mean, yeah, he's really good. Really good.
No wonder I'm saying.
I probably need to come up with a better one this year. That's what I came up with last year. So the guiding questions are just supposed to help you. You need to have them answered by the end of the activity, or some of them you can answer, before the activity starts, like such as what are the materials, and I do give them that list. But I wanted to show you a couple pictures of the actual challenge. The students use a variety of ways. Someone put on the guiding question, what's the density of water? That's really important for this and key. Air and oxygen is very important and key for this as well. So I gave him 2 balloons, a tube. And by the way, this lesson was modified from Paul Schember's lesson. I don't know if anyone teaches with him at Norwood. And in collaboration also with Thomas Haas, who's sitting right there, he did that in his classroom as well. So we've got a lot of different resources if you'd like to try something with this. They use masking tape. A lot of them, I had a drill, I drilled holes in them. A lot of them wanted to put rocks, a ton of weight in it, so the water got really brown. That really wasn't key. But I let them do it, so I had to change the water a lot. So that's it. So do you want to close this out, Lillian?
All right, so we want to thank Kelly and Catherine. But before we leave today, we want you to take a couple minutes to reflect about what you learned. We don't want you to leave. We know it's Friday and you're ready to get out here and start your weekend. But hopefully you've had some good learning today. And I know some of you are already used CDLs, but hopefully this sparks some different interest in you. So if you would please take about 5 minutes, jot down a few of your thoughts in today's meeting and reflection. And also you have a little sheet that looks like, let me see if I can talk in the table. It's like this. A half sheet that asks for strengths, concerns, and questions. We're going to ask that after you've done your reflection, that you please do this, okay? And then we're going to see if Julie has questions that comments she needs to make to help us before. Okay, so take 5 minutes to do that. And then do your evaluation, then we'll wrap you up and get you out of
Unless you
here.
just want to use that, have them put everything under reflection, as long
Okay,
as you share it
so
with
if
me,
you want to
that's
do, so
fine.
you don't need this, we can
No,
just share it.
if you share that with me, that's great, that's all
Okay.
I need.
Yes, Michelle?
I was gonna say, I don't have to reflection.
Okay, so don't worry about filling out the white sheet because we'll just share your reflection with you. You have- you have-
Yes,
I get that 180 as far as this one.